Good morning, students. Now, some questions based on energy of capacitor charging and discharging. See, exercise 2.27. What is question? A 4 microfarad capacitor is charged to 200 volt. Then it is disconnected from battery and connected to another uncharged 2 microfarad capacitor. Then during this process, what is energy loss? That we have to find. Again, understand question. 4 microfarad capacitor is charged by 200 volt. Then it is connected from battery and connected in parallel with 2 microfarad uncharged capacitor. Then your question is, find what is loss of energy. See, very easy. Initial condition. 4 microfarad capacitor C1 is charged by 200 volt. So C1 and it is V, C and V. So I can say initial charge, total charge stored on this capacitor. Okay. Q is equal to C1V. 4 into 200 is 800 microcoulomb. Easy. Okay. What is initial energy? As it is initial case. Okay. What is initial energy? Initial energy Ui is equal to half C1V square. What is value of C1? 4 microfarad. What is value of V? 200. If you calculate this, you will get 80,000 microjoule. Clear? So it is initial case. Now this capacitor is disconnected from battery and connected with another capacitor having 2 microfarad capacitance and uncharged. See what happens when this charged capacitor is connected with this uncharged capacitor. Then charge flows from one capacitor to another capacitor. Okay, this capacitor gets discharged and this capacitor gets charging. Clear? If you connect power bank with mobile, what happens? You know, charge on power bank decreases and charge on mobile increases. Clear? So similarly, when these two capacitors are connected, charge flows from C1 to C2 until their potential becomes same. Because we know charge flows due to potential difference. If potential becomes same, potential difference is 0, motion of charges stops. Motion of charges stops. So yes, when these two capacitors are connected, charge flows until their potential becomes same. And see, as charge is flowing, so initial charge on this capacitor was Q. Initially this capacitor was uncharged, means total charge was 0. Now as charge is flowing, charges on them are, we are assuming, see, let after connection charges on them are Q1 and Q2. Let after connection charges on them are Q1 and Q2. On this capacitor Q1, on this capacitor Q2. So what is total final charge? Total final charge is equal to Q1 plus Q2. Clear? Okay. Now as potential difference becomes same, so we can write V1 is equal to V2. Potential difference between two plates of this capacitor is equal to potential difference between two plates of this capacitor. So V1 is equal to V2. V is equal to Q upon C. So V1, Q1 upon C1, Q2 upon C2. Q1 upon Q2 is equal to C1 upon C2. If you take component in numerator, Q1 plus Q2 upon Q2 is equal to C1 plus C2 upon C2. Now see, what is total initial charge? Q. Total initial charge is Q. What is total final charge? Q1 plus Q2. Then according to law of conservation of charge, we can write law of conservation of charge. We can write total initial charge is equal to total final charge. Q is equal to Q1 plus Q2. So here in this step, this Q1 plus Q2 is replaced by total initial charge. Okay. So Q upon Q2 is equal to C1 plus C2 upon C2. If you make this Q2 as subject, Q C2 upon C1 plus C2. Hello students, you have to remember this equation. Okay. When two capacitors are connected, okay, having capacitances C1 and C2, then what is charge on capacitors Q2, and similarly Q1, it is QC1 upon C1 plus C2. So see, you have to remember these equations. You have to remember these two equations. Okay, if two capacitors are connected like this, what is charges on them? Okay. Now Q1, Q total charge 800, C1 4, C1 plus C2 4 plus 2. Your answer will be in microjoule. That is 533.33 microjoule. Clear? Similarly, find Q2. 800 into 2 divided by 4 plus 2 is equal to 266.67. Now, how to verify your answer? See, what is total charge? 800. What is total initial charge? 800. After connection, charge on first capacitor 533.33 microjoule. After connection, charge on second capacitor 266.67. If you add Q1 plus Q2, yes, it will be 800. It will be 800 according to law of conservation of charge. Now, how to find connection? After connection, how to find energy? After connection, energy is stored in first capacitor. Q1 square upon 2C1. Put value of Q1, 2C1. Your answer is in microjoule. Okay, 35555.11 microjoule. After connection, energy stored in second capacitor. Q2 square upon 2C2. It is equation that we have derived. Fine, you will get your answer. So what is total final energy? In final connection, we have two capacitors. So total final energy is equal to UF is equal to U1 plus U2. And if you add this to energy, you will get 53333.33 microjoule. Clear? You have to find what is loss of energy. See, what is initial energy? 80,000 microjoule. What is final energy? 53,333.33 microjoule. So what is loss of energy? Energy lost delta U is equal to initial energy minus final energy is equal to 26,666.67 microjoule. Clear? So it is one IMP question based on charging, discharging and energy loss in connection. Okay, pause your video and write down from board. Another question, okay, same question with a small change. See, what is data? Example 2.10. 900 picofarad capacitor is charged by 100 volt. Find what is total initial energy. If it is disconnected from battery and connected to another identical uncharged capacitor. Remember, another identical uncharged capacitor. Then what is energy? See, it is same matter. It is same matter. See, first of all, case 1. C1 is equal to 900 picofarad. Charged by 100 volt. So C1 V total initial charge Q is equal to C1 V 900 into 100 90,000 picocoulomb. Okay. Initial energy, total initial energy UI is equal to half C1 V square. Half C1 900 V 100, it is 450000 picojoule. Or you can write 4.5 into 10 raised to minus 6 joule. Clear? Simple. Just calculation. Okay. Now this battery is disconnected and this capacitor is connected to another identical. Identical means capacitance same. Capacitance same, but uncharged capacitor. Now you know that when charged capacitor is connected with uncharged capacitor, what happens? Yes, this capacitor gets discharged and it is charged. Means charge flows until their potential becomes same. Until their potential becomes same. So charge on this capacitor decreases and charge on this capacitor increases. I am assuming let after connection charges on them are Q1 and Q2. So what is total final charge? Total final charge is equal to Q1 plus Q2. Now see here, there is one interesting thing. See here, potential difference V is same because charge will flow until their potential becomes same. Okay, now capacitors are identical means their capacitance is same. Their capacitance is same. So out of three variables, V, potential is same. C, capacitance is same, means charge on them are also same, equal. Charge on them are also equal. How to remember simply, okay? Here when you have two identical capacitors, then charge is equally distributed on them. Charge is equally distributed on them. See how to write. After connection, charges on them are equal. That is Q1 is equal to Q2. Why Q1 is equal to Q2? Because capacitances are same, okay, and potential is also same. So if you write, see here, if you write V1 is equal to V2, what is equation of V1? Q1 upon C1 is equal to Q2 upon C2. This C1 C2 cancel out. Then Q1 is equal to Q2, means charges on them after connection are equal. So after connection, charge on them are equal. Q1 is equal to Q2. Now according to law of conservation of charge, total charge is Q. Final charge is Q1 plus Q2. So Q is equal to Q1 plus Q1. So Q1 is equal to Q by 2. It means this total charge is equally distributed on them. This total charge is equally distributed on them. So Q1 is equal to total charge divided by 2. It is 45,000 picocoulomb. See, 90,000 divided by 2. Q2 is also 45,000 picocoulomb. Clear? Now what to find? After connection, energy of first capacitor U1 is equal to Q1 square upon 2C1 is equal to this. Okay. Now after connection, energy of second capacitor U2 is equal to this. Yes. What is total energy? Final energy UF is equal to U1 plus Q2. UF is equal to this. Okay. So yes, it is your answer. But for MCQ purpose, for MCQ part, what is conclusion of this whole sum? See what is total energy. What is total energy? Observe what is total energy. See, it is 4500,000 picojoule. After connection with identical uncharged capacitor, what is energy of each capacitor? See, it is equal. And see, it is nothing but this initial energy divided by 4. This initial energy divided by 4. Also, this total final energy is half of initial total energy. So if you want to write, what is conclusion? If initial energy of capacitor is U, it is connected with identical uncharged capacitor, then after connection, energy of each capacitor is U by 4 and total energy of system is U by 2. Means U by 2 energy is lost. U by 2 energy is lost. So you have to remember this thing. Clear? Now, it is example 2.10. You have similar question in exercise 2.11. Similar question, just two data change, capacitor and voltage. Capacitor and voltage. Baki question is same. Okay, this question is as your homework. Pause your video and write down from board. See, next question is example 2.8. What is example 2.8? See, you are given one capacitor. Medium between two plates of capacitor is air. Now, if medium between these two plates of capacitor is replaced as shown in case 2, okay, when another dielectric having dielectric constant K of thickness 3 by 4D but same cross sectional area is placed between two plates of capacitor, then what is change in capacitance? Understand question? Okay, if this air medium is replaced by another dielectric medium like this, partially, okay. So what is change in capacitance? See how to solve. Case 1, two plates of capacitor, medium between them air, distance between them D. Let electric field in this region is E0. Potential difference V0 is equal to E0 into D. Charge on plate of capacitor it is Q0. So capacitance E0 is equal to Q0 upon V0. Clear? E0. 0 indicates initial condition when there is air. Now, when this air dielectric medium is replaced like this, Another dielectric constant K and of size of length 3 by 40 is inserted like this. So see, total distance is D. If thickness of this dielectric is 3 by 40, then in this region there is air in a thickness 1 by 40. Clear? Now, charge on plates of capacitor depends on battery. Depends on battery. It does not depend on this material. Okay. So here, first thing you have to remember: if you do not change battery, if you do not change connection, then charge Q0 remaining same. Charge Q0 on these plates remains same. Here on plate charge is Q0. Here on plate charge is Q0. Okay. What is change? Potential difference, because electric field in this region is changed. Now how to find potential difference? See, now we can say between two plates there are two medium. First, this dielectric having dielectric constant K, and another is air. And see, these two mediums forms two capacitors. It forms two capacitors. One this dielectric and one this air. And yes, they are in series connection. So for such a series connection, or simply potential difference between two ends of plates is equal to potential difference across this dielectric, potential difference across air. So how to write V is equal to V air plus V dielectric. Okay. Now we know what is the equation of V. V is equal to E. V is equal to E. V air means potential difference in this region. Okay. In this region it is air, and in air what is electric field? E0. What is thickness? 1 by 40. Yes, it is clear. For this dielectric, in dielectric what is electric field? It is E. And what is its thickness? It is 3 by 40. Clear about this equation? Okay. Now this term as it is E0 d by 4. You can write E is equal to E0 upon K. Yes, we have discussed in the last lecture. E is equal to E0 upon K. E is equal to E0 upon K. 3D by 4. Now if you take E0D upon 4, E0 upon D4 common, then you can write 1 plus 3 by K. Now E0D, see here, E0D is equal to V0. Then this E0D is replaced by V0. So V is equal to V0 by 4, K plus 3 upon K. So what is new capacitance? Here charge on plates of capacitor remains same. Only potential difference is changed due to change in medium. So new capacitance C is equal to Q0 upon V. C is equal to Q0. Put value of V. Take simplification. Q0 upon V0 is called C0. So C is equal to 4K upon K plus 3 C0. Clear? So it is one question based on change in capacitance due to another dielectric medium. Clear? Pause your video and write down for